You are watching Science Tech channel. If you are new, subscribe this channel and click the bell icon for new notifications. We have seen many things in the universe. There are many things in our universe which has no more conclusion. One of the things which has no more conclusion is a strange giant, and that is nothing but black hole. Today in this video, we are going to learn some interesting things about black hole. Firstly, what is a black hole? A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. How are these black holes known to us? Most famously, black holes were predicted by Einstein's theory of general relativity, and then the term black hole was coined many years later in 1967 by John Wheeler. Later, the black holes proven and characterized by Carl Schwarzschild and David Finkelstein. How do black holes form? Stars shine due to burning of hydrogen gas. When these hydrogen atoms are combined to form helium, it is called nuclear fusion. Due to this nuclear fusion, high amount of radiation will emit from the star's core. Similarly, in the opposite way, the gravity will act on the core. Due to these opposite forces acting on the star will remain stable. After burning for a million years, the amount of hydrogen will slowly decrease and the hydrogen will be no more. At that time, the process of nuclear reactions will get stopped. Now, the only gravitational force will act on the star's core. Due to this, the whole star will become like a small ball. Then, the whole mass of the star is concentrated at the core. This core will have a very high density and a lot of pressure will create at the core. Then, at last, the core will blast. This phenomenon is known as supernova explosion. Due to the size of star, we can determine neutron star and black holes. Types of black holes. If a star of 20 times more than the sun is subjected to supernova, then it turns into stellar black hole. If a star of million of times more than the sun is subjected to supernova, then it turns into a supermassive black hole. Now, coming to the parts of black hole. Mainly, black holes have three layers. They are outer event horizon, inner event horizon, and singularity. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The center of the black hole is termed as singularity. The distance between singularity and event horizon is known as Schwarzschild's radius. It is approximately 12 million kilometers. Now, once recall our solar system. In solar system, the planets revolve around the sun due to sun's gravitational force. Right. Now, come back to our black hole. Black holes has high gravitational force which is several times more than the sun. Because of that high gravitational force, the black holes can even trap the light also. Can we estimate the escape velocity of black holes? What is this escape velocity? Let's see. Escape velocity means the lowest velocity which a body must have in order to escape the gravitational attraction of a particular thing. For example, the escape velocity of Earth is 11.2 km per second. The escape velocity of Mars is 5.03 km per second. Similarly, the escape velocity of black hole is almost more than the speed of light. And there is no such thing in the universe which travels more than the speed of light. When one's light falls on black hole, it does not reflect. Many people have a major doubt that light has no mass and it is trapped into the black hole. Why this is happening? To solve this doubt, we have to recall the great scientist Albert Einstein. He said that light is a combination of several photons, and we know that photons have mass. So, because of these photons, the light is trapped into the black holes. How can we identify the black holes? As black hole attracts every object, we can't able to find the black holes. But how the scientists are observing the black holes in the space? Scientists can't directly observe black holes with telescopes that detect X-rays or other form of electromagnetic radiation. We can, however, infer the presence of black holes and study them by detecting their effect on other matter nearby. And the nearest black hole to the Earth is Sagittarius A star, which is 1000 light years away from the Earth. Can you imagine the time in a black hole? As you get closer to a black hole, the flow of time slows down compared to the flow of time far from the hole. This is due to the Einstein's theory. Any massive body, including Earth, produces this effect. Inside the black hole, the flow of time itself draws falling objects into the center of black hole. As everything in the universe has a death, similarly, black holes also die. Black holes have a finite lifetime due to the emission of Hawking radiation. As Stephen Hawking says, the black holes would evaporate. During evaporation, the black hole emits energy in the form of positive particles that escape. So, we can say the black hole also die, but it takes more time to evaporate. This is the whole history of strange black holes. Thank you.